Hey, Miss Nguyen here with our direct variation notes. Okay, so let's just get right to it. Direct variation describes a relationship between two variables that is proportional. And here variables is a word that is talking about stuff like x or y, letters that stand in for unknown numbers, those are variables. Okay? A proportional relationship is one that has a constant rate of change. Right? What does that mean? So here's a very good example of a proportional relationship, and that is hours that you work. Like you have a part-time job, you get paid by the hour. Let's say you get paid $10 an hour. Okay? Now, that's a proportional relationship because the amount of money that you make on your paycheck is directly related to how many hours you work. Okay, so let's say 1 week you work 5 hours. That means at $10 an hour you make $50, right? Well, if you work 10 hours that week, then you'll make $100, and so on and so forth. So you can see that the more hours you work, the higher your pay gets, but it always goes up by 10 each time. Right? That is a constant rate of change because the rate that your pay is changing is $10, and that's always going to stay the same. So an example of a non-proportional relationship would be a waiter, because waiters get paid like $3 an hour, but they make most of their money off of tips, and tips are not constant. Right? Like 1 hour, it might be really popular and make $100 in tips. Then maybe in the next hour, nobody comes to the restaurant and they only make like $5 in tips. So that's not a constant rate of change because it could change anywhere from between $10, $100, $50. That's not constant. So that's a non-proportional relationship. So the kind of problems we're looking at are just the proportional ones, just the ones that have the constant rate of change. Okay. And you may have done some of this last year in 7th grade, but with 8th grade we have more of an emphasis on word problems, right? So situations or relationships that vary directly are represented by the equation y equals k times x. Okay. Remember, when you have two variables or two numbers that are next to each other like that, it means that you're multiplying them. So if you were to read this sentence or this equation out loud, you would read it as y equals k times x. The variable k is the constant of proportionality, or the ratio of y over x. Okay? K is the constant of proportionality, or the ratio of y over x. And that's very fancy words. K is our rate of change. Like, like the $10 per hour, that's K. To find the constant of proportionality, we divide the y value by the x value. So that's right here with the y over x, that's division. So to find K, we take y and we divide it by x. All right? So let's look at these basic problems, and remember you can pause this video anytime if you need to for the notes. So in each of these problems below, assume that y varies directly with x. Given x and y, find the value of k. So as we know, k equals y divided by x. This problem is telling us that y equals 6 and x equals 12, so k equals 6 over 12, and then we need to simplify this. The nice thing is, if you don't know how to do this on your own, you can just type this into the Desmos calculator. When you type in 6 over 12 and you hit the fraction button, it will reduce the fraction for you into its simplest form. So in this case, it's 1/2. So this just becomes 1/2, and that's our answer. Okay. So now let's look at number 2. We're going to do the exact same thing. So maybe if you want to pause here and try it on your own really quick, you could. K equals y over x. So that's going to be, our y is -5, and our x is 15. So when we reduce this, we can divide the top and the bottom by 5, and we get -1/3. Okay, and now here is really a good time for you to pause and see if you can try these two on your own first before you listen to my explanation. Right, hopefully you did it on your own. So k equals 28/14, which is just 2. For this one, k equals -2 divided by -10. When you have two negatives, they cancel out and become positive. So this is +1/5. All right, not so bad. All right, so like I said earlier, in 8th grade, our focus is on the word problems. So using a lot of those same concepts, we are now going to apply it to word problems. There's two key phrases that you want to look for with these that are your red flag, like, oh, this is a direct variation problem, so I need to do y/x. The first one is varies directly with, and then the other one is directly proportional, it's hard to type and talk at the same time, directly proportional to. So those are two phrases that are your signal, your clue, that it's a direct variation problem. Now, that's not always the case. Sometimes they don't have that. So direct variation problems won't always use those phrases, but usually will. And I'll put that here. So from time to time on a worksheet, you'll see a problem where you can kind of tell from the setup that it's direct variation, but they might not use those two phrases. But looking at the STAR test, every direct variation problem that's come up so far in the last couple of years has always used that varies directly with phrase, so that's a good one to know. Alright, so in order to solve a direct variation word problem, we need to follow a few steps. And so these steps, when you hear them, it might not make sense right away, but once we do the practice problem with them, you'll understand what I mean. So for now, just hang in there. So step 1 is we want to label two pairs of x and y. Right? Remember, y is the dependent variable and x is independent. This means that y changes because of x, not the other way around. Right? So in that example I used earlier with how much you get paid, like working at a part-time job, your money, the money that you make on your paycheck, is dependent on how many hours you work. So that means the hours you work is the independent variable, that's x, and the money you make is dependent, that we're going to label that as y. A good rule of thumb in general is when you are looking at a word problem, if there's anything that has to do with time, weeks, months, days, hours, that's almost always going to be the independent variable, because time is independent of everything. No matter what we as humans do, time always moves around at the same rate, right? So time is usually independent, and then anything else, money, number of push-ups, miles, whatever, that's going to be our dependent variable. One of these variables will be our unknown that we have to solve for, because we will have two pairs of x and y, so we should have two x's and two y's, but one of them will be missing. So we'll be either missing a y or an x, and that's going to be the unknown that we solve for. So step 2, we set up two proportions, and we want to set them equal to each other. And important, we want to make sure that in both proportions you have y over x. So y always goes on the top, x always goes on the bottom. That's very important, and you have to be consistent with labeling. Step 3, we're going to use cross multiplication, or one of your previous teachers might have also called it the butterfly method. I guess because when you do the little circles, it looks like a butterfly. So you use that so that we have one equation. And so once you've multiplied everything out, our last step is to divide to get the variable by itself and find the answer. Okay? So let's try doing that with an actual problem. Let's practice each step on this problem together. Okay? And here is where I want to also introduce to some of you this text-to-speech feature in Kami, which can be really useful. So if you're the type of person that likes to hear things read to you, this can be really helpful, and you just highlight it and it'll go. Right? For now, I'll read it and you can hear my lovely voice. Frank just got a new part-time job. His weekly pay varies directly with, so there's that important phrase, varies directly with the number of hours he works. 2 weeks ago, Frank worked for 27 hours and made $336.15. Last week, he had to work a little overtime for 32 hours. How much pay can Frank expect for that week's paycheck? Right? So let's go through each step, and I'll do each step in a different color so that makes it a little easier to follow along. Step 1. Label the X's and Y's. We need to think, is Frank's pay dependent on how much he works, or is how much he works dependent on his pay? Well, like I said earlier, time is pretty much always going to be the independent variable. So the hours, 27 hours, is going to be our X. And then over here, we have 32 hours. That's another X. So if his pay is dependent on how much he works, then that means that the other thing in this relationship, the money, that's going to be our Y. So we have one pair, here's an X and a Y that go together, and then last week he had to work overtime for 32 hours. We don't know how much he made. That's what we're trying to figure out. So this question here, how much pay can he expect? That's our missing Y right there. Okay, so now we have both of our pairs. So our variable that is our unknown is Y. We're missing one of the money, like how much pay can he expect, how much money is he going to get. We need to solve this direct variation problem to find out. So that was step 1. Step 2 is we are going to set up our proportions. So I'm going to do that in green next. So we're going to set up 2 proportions, and they have to be Y over X. Y on top, X on the bottom. So we look back to what we wrote in the problem. We see our first Y is 336.15. So we'll just write that there. Y goes on top. And then the X that goes with that is 27 hours. He worked 27 hours, he made $336.15. Those two go together. Equals the other proportion. We don't know what the other Y is. That's what we're trying to find out. So we're just going to leave it as Y. We don't know, that's our unknown. But we do have the other X, which is 32 hours. So in 32 hours of work, he will make how much money? That's what we're trying to find out. So step 2, done. Step 3, we are going to now cross multiply. It's the butterfly method. So let's start with this side. I'm going to multiply 336.15 times 32. And as we move into doing equations, you will see me using these parentheses a lot. When you have a number next to another number in parentheses, you are multiplying them together. I try to avoid doing stuff like this, because when we do equations and you look at that, it's like, is that a multiplication sign or is that a variable? Is that X, like our variable X? It could be very confusing. And so I like to use the parentheses instead. Okay, so this still means 336.15 times 32 equals, now we need the other side, so we multiply these. It's 27 times Y. Bam. Okay, so now we can go ahead and multiply these two out. They're on the same side. It just makes it easier. So when we multiply 336.15 times 32, we get 10,756.8. So we'll fill this out. 10,756.8. And then we didn't do anything on the right, so we can just leave that just the way it is, 27y. And that is it for step 3. We did our cross multiplication. So our last step is to divide. We want to get y by itself. Okay? So in order to do that, we need to get rid of this 27. This is 27 times y, so that's why we have to divide to get rid of this thing that's being multiplied. So you always kind of want to divide by the thing you're trying to get rid of. So you're trying to get rid of this 27 that's stuck to the y, so we divide both sides by 27. Because if you divide on here, you have to divide on this side too in order to keep both sides of the equal sign equal, right? So when we do that, 27 divided by 27 is 1, so that goes away and leaves us with y. And then we do 10,756.8 divided by 27. Take our answer. Divided by 27. And we get 398.4 as our answer. And so, since this is money, we can put this in money format, and that means that our answer is $398.40. And so with 32 hours of work, Frank would be able to make $398.40. And that's how we get our answer. And that's really about it. The third page of these notes are the independent practice, and so what you need to do is go through each one and work that out. And if you need to check the answers with me later, you can. But that each of these is that type of problem. You need to go through and follow step by step. So like look at number 2 as an example. We got miles and minutes. So remember, minutes, that's a unit of time. So this is going to be our x, this is going to be our y. So you label everything, you set up your proportion, cross multiply, and divide. It sounds like a lot when I list it out like that, but as you can see from our examples, it's really not so bad. Okay, well, I hope that this was useful for you. If you have any questions, you know how to find me, let me know. But that's about it for today, and I will see you in class. Bye.